Afternoon, everybody. My name is Julien, and I'm a tech evangelist with AWS, and I focus on AI and machine learning. And it's good to be back in Poland once again. So today we're going to talk about a number of services that let literally any developer, even if you have no machine learning, no AI skill at all, that lets you add pretty sophisticated AI capabilities to your apps. Okay, so we're going to look quickly at those services, and I have a ton of demos I want to show you. Okay, so I want to make sure you get to see that. Okay, let's get started. So, like I said, our mission when it comes to machine learning and AI is to let everybody in the room use it, right? We don't believe that this should be only for experts, people who have a PhD or something. It should really be for every developer, even if you're a junior developer and you know all you can do is call APIs. That's fine, because the services I'm going to talk about today are really API services, very high level, and they get the job done with minimal fuss, minimal problem. So this is what we're after here. And actually, it seems to be working because we have a ton of customers who are running machine learning and AI workloads on AWS. And of course, you find the really big ones, you know, Netflix and NASA and Intel and very large banks, et cetera, et cetera. And it's okay. You could expect those guys to have data science teams, machine learning teams, training their own models, et cetera. But we also have a ton of much smaller companies, startups, and just normal companies who don't want to invest any time or resources in building AI models. They just want to get the job done, right? They just want to solve their business problem. So actually, it didn't fit on one slide, so I had to put 2 slides, and pretty soon it's going to be 3, which is great, I guess. Okay, so I'll give you some customers example as we go. So the stack today looks like this. We have a high-level layer of application services, and these are the ones we're going to focus on today. API services, most of them in real time. Just call an API, get the job done for image recognition, video recognition, translation, text-to-speech, speech-to-text, etc., etc. These work fine, and they're quite popular. But sometimes you just need to train on your own data, and you just need to work with your own models, and you need more control, right? So we also have a layer of platform services. The main one today is called SageMaker. I'm not going to talk about it today, but I'll share some resources at the end. So if you have the expertise to train your own model, tweak it, etc., then probably SageMaker is what you're looking for. And at the lowest level, obviously, you can always fire up EC2 instances, CPU instances, GPU instances, and deploy any kind of machine learning algo or deep learning algo and just get the job done. That works too. But for today, we're really going to focus on the high level. So the first service I want to talk about is called Rekognition with a K. It came out about 1.5 years ago now, and it's all about understanding visual context. Okay. So we can do plenty of things. I'm going to show you some of these things today. We can do object detection, understand what's in a picture. We could do facial analysis, detect faces in pictures, find attributes about those faces. We can compare faces. We can detect unsafe, explicit content. We can detect celebrities, and we can read text and images. Okay, we're going to see some of those. So object detection is pretty much what you would expect. Okay, pass an image, call an API, and in real time you get back some labels that describe the context of the image with a confidence score. Okay, this is just an example, and here you have maybe 10 labels, but you can get many more than that. Okay, so just really quick, no training required, just call that API, get the job done. Facial analysis will detect faces in pictures. Okay, so here it's a single face, but we could have many different faces. For each of them, we'll give you what we call the bounding box, so the coordinates of the actual face, plus some attributes, male, female, age range, emotion detection, attributes like sunglasses, etc., wearing a Glasses, sunglasses, beard, mustache, that kind of thing. Okay, again, this is just an extract of the information that you get. This is a picture that I took at a workshop in India a couple of months ago. Just a big selfie with a group. And as you can see, using the information returned by Rekognition, it's pretty easy to find all the faces and, of course, the position of the eyes, the nose, etc., etc. And all of those guys were successfully detected. Well, except my colleague down there, but half his face is missing. So, to Rekognition, I guess he doesn't look very human. Okay, but everybody else was correctly picked up. And we can find up to 100 people in a picture. Okay, it's a limit that we set to keep good performance. We can also do face comparison. So here you take two pictures, you look at all the faces on the first picture, and you try to match them to the faces in the second picture. Okay, so here it's really 1 versus 3, but we could have 10 people here and 10 people here. It would work too. So we look at all the pairs and we match the correct ones. So obviously this girl here is the same as here, right? And the others are different. Okay, again, all of this in real time. Image moderation is really important if you have, if you run a website and you want to make sure the content that people upload is okay, right? And the definition of okay might be very different from one website to another. Okay, if you have a fashion website, I guess this is okay, right? If you have a family oriented or a kid oriented or maybe a religious website, that's probably not okay, right? And in some cultures, I guess this is never okay. So this service will just tell you what it is, right? It's not judging, it's just telling you, okay, I see swimwear, or I see partial nudity, or maybe I see a lot of nudity. And then you decide what to do with this content. Okay, you decide if you want to use it or not. Celebrity detection is pretty obvious. We built a collection of movie stars, artists, politicians, etc., etc. And we can obviously detect the face in the picture, but we can also match it to the actual name of that person. And we provide extra information. It could be a Wikipedia URL, or it could be a IMDb URL for actors, for example. And text in image, again, is pretty much what you would expect. Detecting text in images, right? So I guess that's a good name. Typically, this is what you get when you call Rekognition, when the response is a JSON document with all the information. Okay, so in this case, we get the bounding box for the text, and we get the actual text here. Okay, and if you have multiple lines, we get lines and we get individual words. So we can know exactly where a word is. So it's not an OCR solution. It's not, I don't think it's been trained on handwriting. It's really more about text in pictures, text in signs, logos, that kind of thing. I've done some testing with handwriting in big block letters, and sometimes it works okay if I pay attention to how I write. If you have printed text, it does work pretty well. Right? It does work pretty well because it's obviously it's perfect text compared to my bad handwriting. Here's an example of a customer using Rekognition. It's an organization called Marinus Analytics, and in a nutshell, what they do is they build a software solution for law enforcement that lets police officers find missing kids on the internet, right? Missing people, but specifically missing kids. So you can build a database from all the pictures of the missing kids, and then automatically that platform goes and crawls, all the ugly and dirty websites on the internet, and God knows there's no shortage of that. And it tries to match the pictures of the people and the kids it finds there to the database they've built. Okay, and obviously it's not something you could do manually, right? If you were looking for 5 people in a collection of 50 people, okay, any one of us can do that. A kid can do that. But if you're looking for thousands and maybe tens of thousands of kids on the internet, you could have 10,000 people trying to do that all day. It would not be enough, right? And so the scalability of Rekognition here is a strong factor. Okay, so let's take a first look at this thing. And I have to put the mic down, but I'm quite loud, so I think you'll hear me. This is how you would do it. This is how you would maybe detect faces. Okay, let's take Java, why not? Okay, while it's around. Might be the last few years for Java. Anyway, not my topic for today. Okay, so here obviously I'm using the AWS SDK for this. And I need to grab credentials. I need to build a client for Rekognition. I build a detect faces request, okay, and using an image that I've already stored in S3. I'll show you the image, but it's called Oktoberfest, so I think you can figure out what that one is, okay. And then I just call that API, right? Detect faces, okay, and then I iterate over the list of face details that I've received, and I just print them out. Okay. So let's try to run this thing, and I need to show you the picture, obviously. Okay, so here's the picture, right? To us, pretty obvious what that is. And so what did Rekognition see? So I see all the, well, actually quite a bit of information here that I received. Okay, and we detected 22 faces. Okay, and for each face, we get, like I said, the bounding box, the age range. Is that person smiling? Does that person wear glasses? What's that person's gender, etc., etc. Right? All the attributes. Here you see emotion detection, etc., etc. And the landmarks, right? Eyes, nose, etc. Okay. And as you can see, it's really one API call. And I'm running on Wi-Fi here. Not the fastest in the world, but the service is extremely fast. So if we look at, if we use that output, actually, whoops. One-hand typing is difficult. And I'm using those the bounding box information to plot what I've found. This is what I get, right? This is what I get. So some of them are actually pretty challenging. Look at those over there, right? They're pretty difficult to find. And there's a weird distortion on the image, right? I think it's called the fisheye effect. Not a specialist here, but that's what it looks like. This guy here is pretty hard to see. This guy here is half hidden, but we still find him. That one I think is crazy, right? This one is pretty difficult. This one is, almost turning his back to us. So we still find that person, right? So, it's pretty good. It's pretty good. So here I just show you I showed you the Java SDK, but we could do this with all the SDKs for all the languages that AWS supports. Let's try quickly face comparison. It's quite similar. So here I've got two pictures. Okay, so that's my reference picture, and this is a picture from an event last year, I think, or 2 years ago. All right, so lots of people here, lots of random things. So let's see if we can match those faces correctly. Okay, so I've got my two images here. I will actually inline the images into the API call. So I need to load them in an input stream, and then build a compare faces request with that information, source image, target image, and then just call the API. Let's try that one. So hopefully it's gonna, yeah. So it says face at, and these are relative coordinates, right? So it's 0.59, 0.51. So it's in the middle of the picture, right? And it is matched at 99.99%, and three others did not match. So, okay. So it's a big picture, right? As you can see, but okay, pretty much in the middle, right? Dead in the middle. Yeah, it's me. I can guarantee it's me. It didn't pick up anyone else, right? And we see that guy's skull over here. So there you go, right? This is as easy as it gets, I think. And all the other APIs pretty much work the same. If you want to do celebrity detection, if you want to do text in image, etc., we'll see some more during the talk. Oh, here we go. Okay, just call an API and in real time get some JSON that you can use. Okay. So Rekognition video is an extension of that service that we launched at reInvent in December. And well, guess what? It does pretty much the same thing, but on video this time. Okay. The additions to this are tracking, obviously, because we have the time dimension, so we can follow a person in a video, and we can do activity detection because. Again, we have the time dimension. So if you have a single picture of me like this, right, you don't know if I'm running or falling. Okay, if you have 30 images, you can tell. Okay, so these are the extra features. Everything works the same. And actually, if you watch the royal wedding just maybe a week or two ago, Sky News used this live to recognize. Celebrities entering the church, right? And David Beckham, everybody in the UK would recognize David Beckham, I think. But some other celebrities or some other foreign celebrities or foreign politicians, not everybody can know everybody. So this is why a service like that is pretty cool. I didn't watch the wedding because I was actually on stage at the time, I think. But if anybody watch it on Sky News, this was Rekognition at work. And so you could build pretty easily things like this, okay? This small movie just to highlight some of the capabilities of Rekognition. So we see this family just moving around. Obviously we can, like I said, we can track them. So we don't know who they are, okay? Obviously. They're not celebrities, I guess. So we'll just call them person 1, person 2, person 3, but we know it's the same person. Okay? Whoops. And then, the same family can show up at your front door for, I guess, a birthday party. So maybe that's your friend over there, that's Bob, okay, and you know Bob, so your door camera will actually match Bob. And you've never met his family before, so you don't know who they are. Okay, but that's good enough, and maybe your smart home can tell you, hey, Bob's at the door, right? And maybe you could unlock the door if you really trust Bob. Okay? And then if somebody's filming this fantastic scene, then you could use Rekognition video to extract metadata and index it, right? And you could say, okay, show me the birthday party videos that I have in my collection. So, well, you could use all those tags to quickly find this information. And of course, if you're a content creator, if you're a movie studio, if you're a TV channel, imagine how important that is, right? And if you ask me why those two guys are arm wrestling at a birthday party for a 10-year-old, I have no idea, right? It's probably a private joke or something here. So this is how you would build it pretty much. So have a camera, it could be a webcam, it could be anything, smartphone camera. With a native client, you can push your video into one of our services called Kinesis Video Streams. Kinesis has been around forever. It's our scalable messaging system. And there's a version of it that is specialized for video streams. So just push your stream live, then connect that to Rekognition that knows how to ingest Kinesis content. You could look at your face collection of families and friends and say, hey, that's Bob at the door, right? In real time, you could match that face. And then you could output that information to another Kinesis stream in real time. Okay, push a message saying, okay, Bob is at the door. And trigger a Lambda function. That would be just a few lines of code, looking at the messages coming and say, hey, okay, Bob's at the door, so I should notify you, right? And then you could use a SNS or a notification service to send an email or send maybe an SMS or any kind of notification to tell you that Bob is actually at the door, right? So how about we try this? So this comes from a blog post that we wrote some time ago. Actually, I'm gonna use my webcam to do this. So don't worry about privacy issues. I'm not storing anything, okay? So if you told your family you were drinking this afternoon, your secret is safe, right? No one will know you're actually at a conference. Okay, let's try that. So what I need to do here, first of all, obviously, is to start my native client. Okay, and this comes from a GitHub repo that you can easily use, and you can see over there, right? So I'm pushing stuff to Kinesis video streams. It will run into Rekognition, and then I should be able to see the stream. So, oh, here we go. So I can only see myself, which is not pleasant. So there's a bit of lag because we have a slow network connection. It's about 16 seconds behind, right? So if you have more bandwidth, it will just be better. So see, now I'm just moving from the screen, okay? And yeah, lighting is a bit difficult, but yeah, we can still see you, right? So you'll see yourself waving in 16 seconds. All right, that's better, thanks. Okay, so now, so this is going through Rekognition, and it's trying to match my face. I have a face collection with just me in it. So here, I'm not on the screen, and actually no one is. Yep, nice try. So it's not detecting anything. But so if I sit in front of this thing again, and we wait for a few seconds. All right. Oh, now it's probably detecting faces, yeah. So it's detecting faces by saying, I don't know who these people are, okay? So now I probably have 1 million messages, okay. So it's quite tiny, it says one unknown person or more. And now it says, it actually said, okay, we need to catch up with those mails. Oh, 2 known persons, so it found me twice. Okay, interesting. Oh, let's try to grab one of those. Okay. Okay, and it says, 1 known person. Okay, so that means I'm seeing a face in here, and I match that face in the collection. So given that there's only 1 person in that collection, it has to be me, right? But again, it could be Bob and everybody else. And that's how you do it. It's not really difficult. And I have to stop it because by now I probably have 2,000 emails. Oops, come on, stop. Die. All right. Yeah, it's gonna down. It says one known person because it's me, right? There you go. I'll clean up my emails later. Okay, so that's pretty easy to do. And if you want to replicate this, there's a version for so if you have Mac or Ubuntu machines and a webcam, super easy. It's based on a JStreamer, so pretty standard. There's a Raspberry Pi version that works as well. I tested it on my Pi, and it works fine if you have a Pi camera. So you have a few options. There might be an Android version, but I didn't try it. Okay, let's move on. So the next one I want to talk about is called Poly, and Poly is text-to-speech service. So pretty easy. We have 25 languages and 50 voices. Okay, so the way you use it is you just provide a text string in your language or in the language you want to actually generate. You select a voice. We have multiple voices per language, like male, female, etc. And in real time, you get a sound sample. And it's not just raw text, right? We support SSML. And
the price of this book is €45.
Okay, so it's not just text to speech. You can also change the intonation, the speed of the speech, etc., etc. And there's another feature. It's a more recent one. I have to show it to you. It's called the breathing effect. So it's SSML again. And we have this breath, a breathing effect, and it's better to listen to it.
Amazon Polly is a service that turns text into lifelike speech, allowing you to create applications that talk and build entirely new categories of speech-enabled products. Amazon Polly is a text-to-speech service that uses advanced deep learning technologies to synthesize speech that sounds like a human voice. With dozens of lifelike voices across a variety of languages, you can select the ideal voice and build speech-enabled applications that work in many different countries.
Okay, so this is the automatic version, right? So Polly will insert the breathing effect when it thinks it's the right time, but you can also be more precise and do things like this.
Wow, that was quite fast. I almost beat my personal best time on this track.
Okay, so you can actually generate very, very live-sounding samples. And by changing the speed, intonation, adding breathing, etc., it sounds extremely realistic. Okay, and we have all these languages that they can play with. And there's Polish. Oh yeah, we have to try it. We have to try it.
Cześć, mam na imię Ewa. Przeczytam każdy tekst, który tutaj wpiszesz.
Okay, I don't speak Polish, but I'm pretty sure she said, "Hi, my name is Eva, and I will read anything that you type here." Yeah? See? I learn languages. And we have to try this guy too.
Cześć, mam na imię Jacek. Przeczytam każdy tekst, który tutaj wpiszesz.
More. See? There you go. Okay, so we can do plenty of silly things with Polly and have some fun. And if you have an Amazon Echo device, this is what you're using, right? This is the Alexa's voice, actually. It's generated with Polly. So Duolingo, I'm quite sure you know those guys. It's a language app, and obviously they generate lots of spoken messages. And they found out that the quality of the voice that you listen to is a very strong factor in how well you learn, right? Which makes sense. If the voice is really good and has a really good accent, then you learn better. So they did an A/B testing with Polly and 6 other providers, and Polly won them all. And so for all the voices, for all the languages that Polly supports, that's what Duolingo is using today. So if you use Duolingo with one of those 25 languages, you're listening to Polly all day. All right, I guess we did the demo. Okay, translate. Oh, this is an obvious one, right? What could that one be doing? So it's real-time translation. So again, API-driven. It will detect the source language automatically. And these are the languages that we support. So we can translate from English to Spanish, Portuguese, German, French, Arabic, simplified Chinese, and from those 6 back to English. And we have all these coming, right? And this is the slide when usually people yell at me and say, "What? No Polish, no Hebrew, no nothing," right? So where's my language? No Swedish, no all of them. They're all complaining, right? So feel free to complain. It's fine. Well, this just came out at reInvent, again 6 months ago. So we'll add more languages. And if you're an AWS customer and you really want Polish to be in there, get in touch with your representative. Go and ask for Polish support in the AWS forums, etc. And it's always the same story. If enough people ask for it, we'll build it. Okay. So I guess the Turkish people and the Czech people know how to complain, right? They complain better. Okay, let's do a quick demo. Okay, so unfortunately, I don't speak Chinese and I don't speak Arabic, which is why I'm really copying and pasting here. And I'm using the AWS command line. And but again, you could use any SDK to do this, right? You could use the Java SDK, the Python SDK. Yes. We don't have Arabic in Poly. So unfortunately, we don't have Arabic and we don't have Chinese. I have the other ones, yeah. But I think actually Poly only reads the Latin alphabet. Now that I think of it, that might be the problem. we don't have Hebrew, so different alphabets are more challenging. But again, they will come. They will come. And like I said, I don't speak Arabic and I don't speak Chinese. But when you look at the translations, they make sense, right? So if some of you speak Arabic or Chinese, you can actually check and tell me if that's no, you cannot check because it's very, very small. So I feel like I'm cheating here. Okay, now you can read. But it looks like proper English to me, right? Now, is that translation super accurate, or does it need some fine-tuning? Maybe it does need some fine-tuning, but even if it does, it's so much faster to translate this, right? Imagine you have a website full of pages that you need to translate, and not all pages are as important. So obviously the top pages, they need to be perfect. So you would definitely want a human translator to go over those and make sure they really are perfect. But if you have, I don't know, maybe product reviews or user comments, etc., and you still want to translate them, but it's lower value content, I guess. So it's not worth paying someone to actually do it. And it's good enough to have this translation, right? Even if it's not perfect, if I went to a Chinese website or an Arabic website and saw this, it's like, okay, I know what this is about. Okay, it's an accelerator in a way. Okay, so here's translate. And the next one I want to talk about is called Transcribe. So Transcribe is one of the new ones as well, and it's the reverse operation from Poly. So Poly is text-to-speech, and Transcribe is speech-to-text. Okay, so this is not real-time. It's quite fast, but it's not real-time. So you pass a sound file. It could be in different formats. It could be in different qualities. We support high-quality audio and low-quality audio, like telephony audio, which is really important if you need to convert phone conversations, call centers. If you want to transcribe this automatically and then do analytics to understand why people are even calling in the first place, that kind of thing, it's important to have telephony audio. So you will have time codes, timestamps, so you know exactly when a certain word has been spoken. If you want to do captioning, of course, it's important. We have we support multiple speakers. So, of course, we're not going to recognize who that is, but we can detect different voices and say, okay, this is speaker 1, speaker 2, back to speaker 1, etc., etc. Okay, so like I said, it's not strictly real-time. So in the interest of time, I can't do a demo, but I can show you how I have done it. So I recorded a sound file, and it sounds like this.
Hello, my name is Julien, and I live in Paris, France. Right now I'm recording a sound file because I would like to test a new service called Amazon Transcribe. This file should be long enough to give me a good sample, and hopefully Transcribe will be able to understand my French accent, and if not, well, that should make for a pretty funny transcription. This should be long enough by now, so let's stop the recording, upload that file, and get some results.
Okay. Thank you, myself. Well, this is what I got. Okay, so my first name is wrong, but that's the way I pronounced it. Okay, because my first name would really be Julien, which probably defeats every single speech-to-text service in the world. Okay, but I guess Polish is just the next level up, right? So we should try your names. If you look at the rest. It's okay. It's not perfect, but it's okay. Funny enough, it doesn't know its own name, right? Because the service name is Amazon Transcribe, not transcribed. But transcribed would be the word, right? So, I guess we need to inject our own service names into that app. We need to train it on recognizing this. The rest is okay. Maybe a few punctuation mistakes, but nothing really bad. So I tried it multiple times. You noticed I spoke a little slower than usual. I'm a pretty fast speaker usually. So I spoke a little slower, and this was really a factor. If I spoke just like that, blah 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 blah, then there were more mistakes. I have to be honest, there were more mistakes. But it's not my native language either. Okay, so this supports English and Spanish. So with native speakers, it does a good job. Accents can be a problem, of course. Okay, but again, it's a new service, and we're still working on it. And again, if this was a phone call to a call center complaining that my gaming console doesn't work, it doesn't really matter that it's exactly perfect. Okay, if I want to run text analytics on this, I just need to understand the entities, the context, etc. So I don't need a pixel perfect translation, if there is such a thing. I don't need a perfect translation. I just need the translation to be good enough that I can extract the intent of that conversation. Of course, if you want to do maybe captioning, right? If you want to extract audio from video and translate it, and it needs to be better. But again, you could proofread this much quicker than it would take you to listen to hours and hours and hours of audio and type it. Okay, so again, it's a good accelerator. Okay, I think I got just one more. Okay, yeah, the last one I want to talk about quickly is comprehend. So comprehend is natural language processing. So it's typically what you would run on text that you transcribed with Transcribe. Okay? And you can use it in two ways. So you can provide a single document, it could be anything, and call one of those APIs, and you would extract entities. So who is this about? So people, organizations, locations, dates, quantities, product names, etc. It's going to pick them up. Key phrases, so the important bits. Okay, so what is important in that text and what isn't. Language, we can accurately detect 100 languages. And sentiment, which is important if you, of course, want to do analytics on customer data, for example. Okay, so that's one way to use it. The other way, which is a little more complicated, it's called topic modeling. And topic modeling will automatically build from a very big collection of documents. Could be millions of documents. The Washington Post uses this, for example. It's going to build automatically a number of topics. Okay, so just throw 1 million documents at this. Say, okay, group them in 10 topics. And automatically comprehend will build 10 topics. And the topic is really a list of related words. And you will also get a score for each document, again, each topic. Okay, so it's a very good way to extract metadata from a huge collection of documents, and then use that metadata to actually find that content. Right? Give me give me 10 documents that score 80% at least on the stock market topic and 50% on US politics. Right? That's much more efficient to look at this information than to go and try to do full text searches or full text indexing or on petabytes of data over there. Okay, so let's try to close things. Let's try to put everything together, because of course all these services are easy to combine, and then you can build very fun things, hopefully. So let's try this one out. Okay, so this is my $1 billion startup idea, right? I want to be able to read signs in real time, maybe as I drive, right? I want to read billboards, I want to detect the language, I want to translate that text to multiple languages, and I want to be able to speak it, right? So imagine you could be driving in any country and you could have an app that reads billboards to you in your own language, right? That's $1 billion startup for sure. So this is the sign that I want to use. It's a Super Bowl ad, and of course it has some text. So how complicated is that? Well, let's try it first.
We've been waiting.
Hemos estado esperando.
Estávamos esperando.
Nous attendions.
Wir haben gewartet.
Okay, so I was able to detect that text correctly in English, detect the fact that it was English, and then translate it to 4 different languages, and then speak those correctly. Okay, so how complicated was that? So I used 4 services. By now, you know which ones. I used Rekognition to detect the text in the image, Comprehend to detect the language, Translate, obviously to translate it, and Poly to speak it and generate the sound files. Okay, and this is the full code. Right? 25 lines or something, including spacing. So this is what it takes, right? It takes 10 or 12 API calls, all real time, and you solve that problem. Okay. A few years ago, trying to do this was, if you had a proper machine learning and deep learning team, if you had a big data set to train on, if you had a lot of infrastructure to train on and budget and everything else, yes, probably you could do it. Okay. But what about all of us, right? What about the normal people? What about normal companies? What about individual developers? Obviously, no one could do that. Okay. Now it's as easy as this, and like I said, any junior developer can write this in maybe an hour. Okay. And when it comes to the cost of this, I can't even tell you because we price all of these API calls per 1,000 calls, and so here I did maybe 10 or 12. So it's fractions of cents. Okay. Obviously, it's fully managed. You never have to worry about a single server. You never have to worry about scaling that thing. If you want to call these APIs 500 times per minute or something, that's fine. You can do that. Okay, it will scale because it's fully managed. Okay, so again, like I said, machine learning, AI, absolutely for everybody. Anyone can write this. Okay, if I can write it, anyone can. That's my conclusion. All right. So this is the family picture, and we talked about most of the services. There's one I didn't talk about, which is Lex, or chatbot service, but I had to cut one in the interest of time. Please get in touch if you're interested in chatbots as well. Again, SageMaker, one of the platform services. If you need to train and on your own data and build your own models, this is really the one you need to look at. And at the lowest level, EC2 instances, the deep learning AMI that provides all of those libraries and the NVIDIA drivers, etc., pre-installed, so that you don't have to install anything ever again, which is good news. So if you want to keep on learning about this thing, I would recommend starting maybe here. That's the high-level page for ML and AI at AWS. And you'll find pointers to all the services that I talked about and case studies, documentation, etc. The AI blog has quite a lot of content, technical articles, etc. And on my own blog, you'll find quite a few posts on machine learning and deep learning, in SageMaker, and the latest one was on PyTorch, I think. So quite a few things. So if you're really into machine learning and deep learning, and you want to learn how to do this best on AWS, I guess my blog is a good location to look at. I have also a ton of talks and tutorials on YouTube, so you might like that. And the code that I showed you today is on GitHub. Oh, no, it's not on GitHub. It's on GitLab now. So long live GitLab, right? And if you want to get in touch later on, Twitter is really the best way, or LinkedIn if you want to. But Twitter is really the best way to get in touch, ask me questions, and ask me to help you out, right? And if you build cool stuff with all of this, please let me know. I'm more than happy to share and retweet all of it, right? That's it. Thank you very much. Thanks for inviting me, and enjoy the rest of your day. Thank you.